Good afternoon, class. My name is Liza Wall, and today I will be presenting my Healthcare Improvement Technology paper entitled Wireless Bluetooth 12-Lead ECG. According to Mechanic et al., there are over 1 million deaths annually in the United States due to myocardial infarction. To improve the outcomes of these victims, the American Heart Association implemented the door-to electrocardiogram interpretation by the provider to take no more than 10 minutes to rule in or rule out an MI. So as you all may know, a 12-lead ECG is a device that allows a trained provider to visualize the electrical activity of the heart. Despite advancements in healthcare information technology, there are still flaws with these applications, contributing to a decrease in patient outcomes. So to clearly and fully identify the clinical goal, the wireless Bluetooth 12-lead ECG aims to increase the door-to ECG 10-minute compliance in rural hospitals, specifically in central Louisiana. So current hit issues include time-consuming equipment preparation, inaccurate data, and lack of providers, which we will discuss in detail in the next few slides. Today, the standard 12-lead ECG is bulky and requires multiple wired connections. These connections or placements are noted in the photo to the left that depicts the locations. So there are two upper limb wires. One is on the left wrist and one is on the right wrist. There are two lower limb wires, one on the left ankle and one on the right ankle. And then there are 6 pericardial wires as noted in the picture to the left as well. All these wires are connected to a central device. These wires tend to decrease user-friendly capabilities in output management. And as you can see from the photo on the bottom, the wires can become easily tangled. And from clinical experience, we also know that patients are not compliant, especially when they are in pain. So they tend to move and further tangling these wires and pulling on these wires, which we will discuss further in the next slide. Another hit issue was inaccurate data, and according to Perez Rodríguez et al., an artifact occurs when there is an electrocardiographic alteration that is captured and unrelated to true cardiac activity. This capture is most commonly the result of movement from a patient and a wired lead connection. This is especially true for patients that are suffering from Parkinson's or another neuromuscular disease, and as previously mentioned, it is also contributed to the movement and pulling of these wires on patients that are in pain. In addition, the body's physiological response to an MI is diaphoresis. This further decreases the appropriate contact required for each ECG pad and leads to placement adjustments, reapplication, and even having to use tape to make sure the pads are secured to the skin. As you can see, this creates a monotonous occurrence until the proper ECG is obtained. These complications intensifies artifacts and delays the door-to ECG interpretation time. Finally, the current design of most 12-lead ECGs is to print the ECG recording for interpretation at bedside with the provider in the room. This is hard in the rural settings where there is a lack of providers, especially when there is more than one emergency occurring within the hospital. In some instances, the ECG is then transmitted into the electronic health record. However, in 2009, the Health Information Technology for Economic and Clinical Health, also known as HITECH Act, was enacted in coordination with the American Recovery and Reinvestment Act of 2009. According to Yin et al., this brought about complications related to the HIT system's improvement, including the understanding of HIT implications, inadequately designed interfaces, and subpar functionality. This required multiple updates and technical reconstruction for smooth interoperability, which is yet to be perfected, thus still requiring the provider to be at bedside. One issue found with the wired 12-lead ECG is the inability to adhere effectively to the diaphoretic skin and the pulling of these wires. However, wireless designs may show promises according to recent developments within the healthcare cardiac realm. These advancements include the wireless monitoring device for everyday wear in the form of smartwatches. Smartwatches can detect arrhythmias and heart rate abnormalities by placing the watch snugly to the wrist. In 2021, Perina et al. Found this device to have a positive predictive value of 0.84. Additionally, a novel dual-chamber leadless pacemaker and monitoring device has recently been employed as a breakthrough technology for arrhythmia detection. Important to note that physical contact between each lead is not required, as one lead is placed in the right atrium and the other in the right ventricle. Here, implant-to-implant communication allows for a communication success rate of 98.3%. In 2022, I was actually able to care for a patient that had this device placed. It was minimally invasive and a quick recovery. As previously discussed, increased communication has led to errors due to interfaces in the electronic medical record. These errors contribute to reception delays and inappropriate data displays from one device to the next. However, blockchain advancements provide the promise of a seamless interoperability across multiple devices without interruption, allowing the providers to rally the appropriate healthcare team to prepare for interventions while simultaneously caring for other emergencies. The literature has shown success for the incorporation of compact devices, accurate electroconductivity analysis through wireless devices, and the ability to transmit data rapidly to nearby providers. As depicted in the background photo, the linkage of these advancements into one device, a wireless Bluetooth 12-lead ECG, may increase positive patient outcomes. Several interventions are critical to achieving the goals and objectives. This includes the defining of stakeholders, completing a comprehensive needs assessment, defining the said goals and objectives, setting interoperability standards, and assessing those standards. There are two types of stakeholders, primary and secondary. According to Ross and Curley 2020, primary stakeholders reap the benefit of the new technology. Primary stakeholders include patient, care staff, computer scientists, engineers, and cybersecurity device specialists. Secondary stakeholders include personnel or entities that indirectly reap the effects of the new technology and improvement in usage. These stakeholders may be insurance agencies, the community, and the production source, manufacturer. Next, a needs assessment should be conducted. A healthcare needs assessment is defined as the process of determining the health and healthcare needs of a given population or subgroup in the area, along with a technology needs assessment, which is defined as the evaluation of the existing environment and capabilities of an organization relative to the preferred environment and capabilities, with the difference between the existing and preferred conditions being defined as the organization's need. A comprehensive needs assessment for both the healthcare and technology required to implement the production and usage of this device. Once a comprehensive needs assessment is completed, the goals and objectives may be defined to provide a clear path for production and implementation. As previously mentioned, the goal for the wireless Bluetooth 12-lead ECG is to increase compliance within the AHA door-to-ECG guidelines in central Louisiana. Having concrete goals allows for the production and implementation to meet the set time limit and redirect focus if needed. Lastly, setting interoperability standards may be achieved by assessing quantitative and qualitative metrics, which we will further discuss in the next slides. Obstacles should be considered to aid in the success of the wireless Bluetooth 12-lead ECG. These obstacles include stakeholders as gatekeepers, such as financing from hospitals and pushback by the hospital care staff, and production delays. The COVID-19 pandemic negatively impacted hospitals across the nation due to increased operating expenses, costs for supplies, and inflated labor costs, creating over a $200 billion loss. Specifically in Louisiana, a prominent chain hospital laid off over 770 employees in Louisiana and Mississippi due to financial hardships. However, these obstacles can be overcome with proper education and mutual goal setting for all parties, and by seeking assistance from private investors, research institutions, and medical device companies. Care staff may be reluctant to change. According to a study by Cho et al. 2021, they concluded that the incorporation of technology negatively impacted nurses' outlook due to resistance to change, unfound usefulness, and ease of use. By providing a comprehensive education on the necessity and a detailed in-service, this may allow the nurses to understand and familiarize themselves before use. Lastly, production delays may occur. The 2019 pandemic also created medical supply shortage. According to the Food and Drug Administration, the device shortage list still includes the diagnostic and monitoring products for cardiac arrhythmias. The employment of research institutions and productions may be an option to combat this issue. In short, obstacles may be avoided through the consistent and highly educational communication between all stakeholders. Implementing the Plan, Do, Check, Act model may also aid in success by recognizing opportunities for change, testing implemented change, reviewing and identifying what was learned, and taking the next action after reviewing completion. Many positive attributes were found throughout the research process. However, the private use of hospital-provided cell phones with blockchain technology shall be initiated from conception. According to Isa et al. 2021, interoperability is quite complex and results in irreconcilable documents and arrangements. The implementation of blockchain aims in reduction of send to receive time from the wireless device to the secured cell phone to display the 12-lead ECG results. Blockchain is defined as the database containing information or a record transaction maintained across several computers that are linked in a network that can be simultaneously used and shared within a large, dispersed, or decentralized accessible network. This is why we will initiate this, so that we can send the interpretation directly to the provider. Blockchain will offer privacy to ensure HIPAA compliance, data exchange, and storage of healthcare data. By encompassing blockchain, miscommunication and interruptions may be completely avoided. Metrics for success will be determined through qualitative and quantitative data. Qualitative success will be determined by the healthcare staff as being user-friendly and reliable during the application process. Accurate assessment of qualitative data will be conducted through a series of anonymous surveys to promote honesty and non-biased judgment. The SMART performance metric will measure qualitative success. The SMART objectives are designed to be specific, measurable, achievable, reliable, and time-bound. Specifically, the wireless Bluetooth 12-lead ECG will be found successful if the number of door-to-ECG guideline non-compliance decreases by 50% from baseline within 1 year. This will be measured through audits and compared to the previous assessments utilizing the Plan, Do, Change Act as previously mentioned. Incrementally increasing targets will be set quarterly to help achieve this goal, along with audits to aid in adjustments as required. To conclude, the wireless Bluetooth 12-lead ECG shows promise for user-friendly capabilities and interoperability, allowing for increased compliance with the American Heart Association guidelines for door-to-ECG interpretation. Advancements in technology such as dual-chamber pacemakers and wearable arrhythmia detection monitors show promise and accuracy for individuals experiencing myocardial infarction. Although challenges may arise, the Plan, Do, Change, Act method may allow for realignment and focus on the end goal. By incorporating blockchain, resistance to interoperability malfunctions may be avoided from conception. Qualitative and quantitative metrics will be analyzed quarterly to assess for strengths and weaknesses throughout the improvement project. The launch and consumption of the wireless Bluetooth 12-lead ECG is no trivial achievement. However, implementation for development and thorough evaluation and precise monitoring with the assistance of computer scientists, engineer, and healthcare staff may allow for the goal of door-to interpretation time in under 10 minutes to be achieved. Here are my references. Thank you for watching.